Hi, this is Group 13's video presentation for the final project. Starting with question 1, the way we graph these CEFs were first we took the raw data off of the Excel sheets, and then on MATLAB we log transformed all of the data sets, and from there we plugged them into the equations for CDFs and graphed the normal CDFs for station 0 and the southern station. As you can see, we used the equation f equals m over n plus 1 with 781 iterations for the given TC values and 3,131 iterations with the TC values for the northern stations and 3,072 iterations for the southern stations. And this is a comparison of all three normal CDFs on one graph, so you can easily see the comparisons that the northern station is the highest, and then the southern station is the next highest, and the zero station is the lowest. For the differences between northern and southern stations is kind of slim compared to the zero station, so we did a hypothesis test. And these are calculations for the northern and the southern stations. For the hypothesis test, we chose a significant level of 5% for the type 1 error. In the northern station, the population parameters are sigma and mu, with a total population of 3131. We took the data from the 15 northern stations, the 15 northern station only, and calculated a sample mean as 254, the standard deviation as 1.645 to the third power, and the sample size of 783. We used a one-sided hypothesis test because we wanted to see if the TC falls under the population mean or if it does not. We selected the null hypothesis as TC mu is equal to 341.3, and the alternative hypothesis test as TC mu is less than 341.3. We used the z-score equation in order to calculate the value, which turned out to be negative 1.472. And according to the probability distribution, the z-score falls outside of the significance level of 5%, and therefore we reject the HA, and the TC grows above 341. For the southern station data, we had an overall population mean of 457.769, standard deviation of 2.051 to the third power, and total population of 3,065. We took the data from the corresponding 15 southern station only and found a sample mean of 215 and a standard deviation of 1.107 to the third power and the sample size of 778. We used again the one-sided hypothesis test, and we stated that the null hypothesis test is the TC mu equals 457.769, and the null test is TC mu is less than 457.769. Again, we use the same procedure, and then the value was negative 6.106, and according to the probability distribution, the z-score falls outside the significance level of 5%. The null hypothesis and the TC grows above 341. For question 2, we had to graph the normal CDF of the transform station 0 northern station and the southern station. As you can see, we used the formula right here, and we decided to go with the log transformation, and we use a transformation for all three CDFs, the same method of using the log transform data and using the CDF equation and doing the log normal distribution calculations, which can be found in the report. And this is a graph comparing the red line, which is the transformation graph, and the black line, which is the normal CDF. As you can see, the normal CDF is a discrete value compared to log transform data, which is a smooth continuous function. And for the most part, they are pretty similar in their curvature. And this is with all of the graphs combined for steps for question 1 and 2. For question 3, we use the same procedure as question 1 and 2 in how we graphed the CDFs for temperature and salinity, except for the fact that we didn't log transform the data. And this is the graph comparing the log transformed CDF of temperature compared to normal CDF, which is in blue. And again, the values are pretty similar, except for one is discrete and one is continuous. However, for the salinity, the graph of the normal CDF is already a smooth continuous function. So when we graphed it compared to the log transformed one, which is in red, it was stayed for the same for the most part. And here are calculations, which can also be found in a report of how we found the parameters of lambda and zeta in order to run the equation for the log normal distribution. Now going to question 4. Here we had to find the extreme values for station 0, the northern station, and the temperatures and the salinity. Hey, Justin. Oh, Justin. Oh, because I realized I already have the equations on there. So as I'm talking, I can just have it there in the background, and then also it's in my report, so I don't need to read through the equation. Huh?
Are you going a little over?
Yeah, so that's why I was like, okay.
You pause a lot too.
Oh no, I do that on purpose, so he has time to look
too.
at the graph. But then I kind of got, that was actually a pretty good run, except
Yeah,
no, I realized I don't need to list every practice here.